So now that we know how to graph inequality statements with intervals and represent them in interval notation, let's talk about how to solve some basic linear inequalities. And the guiding principles for this are a lot like the principles that we use for solving equations. So if I have a is less than b, I can add anything I want to both sides, or subtract anything I want to both sides, and inequality sign does not change. If I'm multiplying and dividing, we have to be a little bit more careful. If I have a is less than b and c is some positive number, then the inequality symbol does not change when I multiply or divide. However, if I'm multiplying or dividing things by a negative number, and that's what the statement 3 says, I have to switch my inequality sign. So you may notice a is less than b here, but after I multiply or divide, the inequality symbol got flipped. So basically all this means is we can treat these like equations when we're solving them. We just have to be very careful when we're multiplying or dividing. So let's take a look at some examples. And for instructions, we are going to solve, graph, and we're going to write set builder and intervals or interval notation. So we're going to see how to solve things. We're going to talk about graphing it. We're going to talk about set builder notation and interval notation for each one of these examples. If you're working on homework or working on a test question, make sure you're following the instructions. Sometimes you'll be asked to give more than one of these. So not just solve, but you might be asked to graph or provide set builder notation or interval notation. So following instructions is always important. So let's look at example 1. Let's look at x plus 5 is less than -2. So if x plus 5 is less than -2, this is very similar to the equation x plus 5 is equal -2, but we're never going to replace this with an equal sign because it's changing the problem. But with an equation, we would subtract 5 from both sides or add -5 to both sides. So let's add the opposite. So x plus 5 plus -5 is less than -2 plus -5. I didn't have to change my inequality symbol here because I'm adding, or actually I'm subtracting, but subtraction is the addition of a negative. So that's basically the same thing. So x is less than -7. So that is solved. I solved that inequality statement. If I want to put it in set builder notation, all I have to do is put that fancy window dressing on it, x, such that x is less than -7. That's it for set builder notation. Graphing a lot of times is a little bit easier than coming up with the interval for a lot of people, especially when we're getting started. So I'm going to look at -7. So x is less than -7, so that means it's going to the left of -7. And I'm going to shade the region to the left. So this tells me what my interval should look like. That's going off indefinitely to the left. So I'm going to get -infinity, and I'm going to go up to -7, but I'm not including it. And so I solved set builder, graph, interval. Let's look at 1/2 times y is bigger than or equal to 5. So if I'm looking at 1/2 times y is bigger than or equal to 5, there's multiplication by a half here. And to undo that, I can multiply both sides by 2. So 2 times 1/2 y is bigger or equal to 2 times 5. I don't change the direction of my inequality symbol here because I'm multiplying by a positive value, and I don't need to worry about that. 2 times 1/2 is 1, so I just get a y, and that's bigger than or equal to 10. So there is my solution, is y is bigger than or equal to 10. Set builder we get for free. And for my interval, I'm looking at the value 10, I'm including it. And since Y marches off to the right, oops, if I was using a paper and pencil, a lot of times I just scribble it in, but I have some better tools. So let me make sure that I highlight, be consistent. So what I did there, the squiggle, a lot of times that's what you'll see on paper pencil, if people only have a pencil or a pen to work with. If you have highlighters or colored pencils, it helps, makes things cleaner and neater. And that is the interval from 5 to infinity. So again, solve, set builder, graph, interval. So I want to make note of my work here. I want to again highlight that I did not switch my inequality signs to equal signs. That would be incorrect. And I stacked everything up nice and neat. I didn't change the directions of any of these because I didn't need to. We only change directions when we multiply or divide by a negative. So let's take a look at something like that. Let's look at negative 3x is bigger than, let's say 2. So negative 3x is bigger than 2. The only operation happening here is multiplication. So I have to either multiply by negative 1/3 or divide by negative 3. Either way, I want to cancel out that negative sign and cancel out that 3. So let's divide both sides by negative 3. And it might sound picky, but I think it's really important here to actually have a new line. Because when I divide by negative 3, this inequality sign has to flip. So it's really important to actually recognize that in this step. So instead of just writing negative 3 underneath up here, which would technically change the problem, write a new line, and that'll make things mathematically correct and everything will flow nicely. And I get a solution of x is less than negative 2/3. Our set builder is free by putting a window dressing on there. And we can graph. So I'm looking at everything to the left of negative 2/3. And that's the beautiful part about this number line thing. If we're not drawing tick marks, don't really care where negative 2/3 is in relation to negative 1 and 0. You could put tick marks if you want, but it's a lot of extra work. And my interval notation is negative infinity to negative 2/3. I'm not including either endpoint. And that is an example where we have to deal with changing that inequality sign. Just like linear equations, things get a little bit more complicated. So let's do 2 more examples. Let's do 2x minus 8 is bigger than or equal to negative 3. So this is going to happen in multiple steps because I have this linear expression on the left-hand side of 2x minus 8. So x is being multiplied by 2 and then subtracted 8. Let's undo the order of operations by adding 8 to both sides. So 2x minus 8 plus 8 bigger than or equal to negative 3 plus 8. I did not change my inequality symbol because I was adding. Adding, subtracting doesn't care. It always stays the same. 2x is bigger than or equal to 5. And dividing both sides by 2, 2x over 2 is bigger or equal to 5 over 2. And x is bigger or equal to 5 halves. Set builder notation, let's graph it. I'm looking at everything to the right of 5 halves, and I'm including 5 halves. I'm going to shade that. And my interval is including 5 halves and going off to positive infinity. And that is a slightly more complicated example. We had a few more steps. Finally, let's look at something with some parentheses. Let's look at, let's see here, 3 times 5 minus x is less than 7. So if I have 3 times 5 minus x is less than 7, we need to clear the parentheses first. So let's distribute, and that's going to be 15 minus 3x is less than 7. It didn't change the inequality sign, just cleaning something up doesn't do anything for changing the inequality sign. But this is a linear equation that we can solve. So let's add negative 15 to both sides. And another reason why I like the subtractions, the addition of a negative is addition commutes, and I can really put that wherever I want. As long as I'm adding negative 15 to both sides, it doesn't matter where it shows up, to the left of everything or the right of everything, because again, addition commutes. So the 15 and negative 15 cancels out. This sign here, this negative 3x, that negative is attached to that value 3 that is also attached to the x. One way to think about that is that sign is a baggage from a previous relationship. We're stuck with it whether we like it or not. 8. So I have negative 3x is less than negative 8. My inequality sign did not change yet, but now I am multiplying by negative 3 on the left-hand side here, which means I have to divide everything by negative 3 again. Negative 3x divided by negative 3. That changes my inequality sign. Negative 8 over negative 3. So negative 3 divided by negative 3 cancels out, and I just get x is bigger than, and I have a double negative here, so it's a positive 8/3. X such that x is bigger than 8/3. And if I graph it, I'm looking at everything to the right of 8/3, but not including. And my interval is 8/3 to infinity. So in the next video, we're going to talk about compound inequalities. And that's so when you have the example was like, say that a is less than x is less than b. That's technically a compound inequality. And we're going to talk about solving things that look more like that in the next video. And I will see you there.